It's a bit different to the traditional modulation techniques, especially OFDM. So let's have a look. So consider the following OFDM transmission system. So just to recap, in a OFDM system, we will have something called the subcarriers. Right, so each of these are called subcarriers, and each of these subcarriers will undergo a particular type of modulation technique, modulation. For example, QPSK, 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 and so on. Right? And with OFDM, we have the flexibility to have different modulation techniques for different subcarriers, increasing the complexity, and also assign no data for certain subcarriers, and we call them as pilot data or reference data. In other words, we have the flexibility not to use subcarriers for data transmission and use other subcarriers for data transmission. And we also have the flexibility to assign multiple subcarriers per user, so per user 1, and then more subcarriers per user 2. Depends whether you're on a $20 subscription or a $150 subscription, the amount of subcarriers that you are assigned to. So what does it relate to again? Amount of subcarriers mean the download or upload data speeds are quite significantly different. So if each subcarrier carries, let's say, 100 kilobits per second, so you just multiply that by the number of subcarriers in a linear way, if the same modulation technique is used, right? So if you need a download speed of 1 megabits per second, you can assign 10 subcarriers over that time period, and so on. So this way of assigning communication resources is much convenient, efficient, and flexible, and that's why OFDM picked up quite significantly. The number of subcarriers, if you go into higher frequency bands, can be in the order of thousands as well. So it's quite high. Okay. So as the question states here, we have an OFDM system. The modulation technique used per subcarrier is BPSK. So BPSK, BPSK, and so on. The number of subcarriers is 128. So we have 128 number of subcarriers. So 1, 2, all the way to 128. And then you can say this is BPSK. Cyclic prefix length is 1 microsecond. So cyclic prefix, now this goes back to the time domain of the OFDM symbol, right? So we get a OFDM symbol that's and the adjacent symbol, and the next symbol, and so on, right? There's a guard time allocated between subsequent symbols, and that guard time is known as a cyclic prefix. Why do we do that? We do that to combat multipath effects, so that when we have multipath effect, we know that first ray comes along and then copies of the same comes afterwards because of the multipath delays. So this guard band will make sure that the copies are, it has got sufficient time to receive the copy, the multipath component before it interferes with the next symbol. Okay, so that's what's called a cyclic prefix. This cyclic prefix, this guard band can be a bunch of zeros, right? But when we put a bunch of zeros, let's say no signals, then the transmission becomes so complex from a signals perspective that the recovery of the data becomes pretty hard. So instead what we do is we copy the first part of the same symbol and paste it at the end for all the symbols. So this is a copy of that, this is a copy of first part of that, and so on. That's why it's called a cyclic prefix of the same symbol. And at the receiver, the cyclic prefix is just discarded and only the actual data is decoded. Right? So it's kind of a guard time between symbols, but and that's filled in by a copy of the same signal from the beginning. So cyclic prefix length is 1 microsecond. So in this case, cyclic prefix is 1 microsecond. And the cyclic prefix and the number of subcarriers, etc., modulation techniques are all fixed for a particular communication system so that the receiver would know how to decode the signal. Right? So you can't have random cyclic prefix values. There are options, like 2 or 3 or 4 options according to the standards where you can alter, but the receiver should be notified of that. Otherwise, you wouldn't know, where the symbol lies, right? If you accidentally discard a different amount of data instead of the cyclic prefix data, then you're losing the data or information. So cyclic prefix is 1 microsecond. Total available bandwidth is 10 megahertz. So the chunk of spectrum that's available for this this system is 10 megahertz. So what do we have? We have a 10 megahertz spectrum that uses OFDM of 128 subcarriers. So 10 megahertz spectrum is split into 128 subcarriers. So that's your OFDM system, right? And been asked a couple of questions. Find the subcarrier spacing of the transmission system. It should be pretty straightforward because the subcarrier spacing is the gap between subsequent or adjacent subcarriers. So if you have a 10 megahertz of spectrum, just need to divide by the number of subcarriers, which is 128. That will give you the subcarrier spacing. Okay. So I would say part A, subcarrier spacing delta F is 10 into 10 to the power of 6 divided by 128. That is 78,125 hertz, or 78.125 kilohertz. So that's the gap between any adjacent subcarriers. Okay. So part B, find the data rate of the OFDM transmission system. If 4 subcarriers are used for carrying pilot carriers and 4 subcarriers are not used. So out of this system here, out of 128 subcarriers, 4 subcarriers are used as pilot. Pilot subcarriers are used for the purpose of synchronization for receiver and so on. In other words, it doesn't carry data. Right? So you cannot use that subcarrier for calculating data transmission. So 4 subcarriers are for pilot,
and for transmitting pilot tones, and another 4 subcarriers are not used. So possibly guard bands at the either ends of the spectrum channel. So in 8 subcarriers are not used for data transmission. So only 120 subcarriers are used for data transmission. So you need to calculate per subcarrier what is the data rate, and then multiply that by 120, so that you will get the total transmission rate of this OFDM system. Okay. So how do we calculate the data rate per subcarrier? Okay. So this is the symbol rate, symbol duration. This is one. Oops. All right, there you go. This is your OFDM symbol, second symbol, third symbol, and so on. Okay. So you draw that again. Yeah. So this is the cyclic prefix. And that's what we call as OFDM block length, right? Which we transmit. And this period here is 1 on delta F. What is the delta F? Delta F is the subcarrier spacings, right? Why is this length 1 on delta F? Because that's the theory, because if you don't have that as 1 on delta F, or multiples of delta F, 1 on delta F, then you will not achieve something called orthogonality. So subcarriers, only when they are orthogonal to each other, they won't interfere with each other. Right? So there need to be sufficient gap between the subcarriers so that you can decode the subcarriers. If the subcarriers are not orthogonal, then when you try to decode a particular subcarrier, the other subcarrier will interfere with that subcarrier. So which then that will reduce your performance. So this is 1 on delta F, this is cyclic prefix, and this is OB, the OFDM block length. So your OB is pretty much 1 on delta F plus cyclic prefix. So 1 on delta F is, we know what delta F is, which is 78,125, plus your cyclic prefix is 1 into 10 to the minus 6, right? So your OFDM block length is 13.8 microsecond. So if that's your symbol, which is the OFDM block length, or which is the OFDM symbol duration, then the data rate per subcarrier let's say data rate per subcarrier is 1 on this OB. There's 1 on 13.8 into 10 to the minus 6 equals 72,464 bits per second, or 72.5 kilobits per second. So this is the data rate. That's carried in a subcarrier. Now this is the symbol rate, right? Because it's 1 over the symbol. But your modulation technique is PPSK, which means that you're only transmitting 1 bit per symbol, right? So your symbol rate becomes your data rate as well. If you use QPSK per carrier, so that means 2 bits per symbol, and you've got to multiply this by 2 to calculate the bit rate, number of bits per symbol. Right? So in this example, it's only PPSK, so that 1 bit per symbol. This is actually your symbol rate, right? That we calculated, but in this case, it's the same as the bit rate because 1 bit per symbol, right? And that is true for per carrier, and therefore total data rate is, let's say, RP 72.464 into 10 to the 3 times 120, because we got about 120 subcarriers. That's I think we ran over time. That gives about 8.695680 megabits per second. Okay. Generally asking it's an over time. Okay. Let's stop there. So, so this is how you calculate transmission rate for OFDM modulation. Okay, so you got to understand how the OFDM modulation is performed, so that you can perform the calculations, right? I think it's clearly explained in the lecture recording as well. But all right, so we'll continue from next week. See you all next week.